Good morning, students. Today we are going to discuss the topic of welding. This is as per the syllabus of Manufacturing Process 1, third semester, Diploma in Mechanical Engineering. I am DPM sir, your teacher. Now, what is welding? Welding is the process of joining two similar or dissimilar metals. So, welding basically is a process of joining two metals. Sometimes it can be three metals also, but they can be similar or dissimilar. Now, it is broadly classified as forge or pressure welding, fusion or non-pressure welding, and cold pressure welding. In pressure welding, heat is applied to the metals to be joined to bring it to plastic state, and pressure is applied to join them. Heat is generated in the following methods: either in a blacksmith's fire, that means in a furnace or in an oven. It can be generated by passing electric current through workpiece or by the process of friction. In fusion welding, heat is generated by electric arc, gas or chemical reaction. Cold pressure welding is recently developed process where two parts are subjected to high pressure, which results in molecular fusion of the parts to be joined. Cold welding is not actually a part of the present syllabus, so we will just know about this process now. You can see this process again when you study powder metallurgy. This process is mainly used for joining non-ferrous materials like aluminium or copper. So first we start with our old gas welding. Now gas welding, the heat is generated by burning gases. It is just like a fuel gas which burns in the kitchen like LPG, and the combustion takes place with the help of oxygen in the air. Now in case of welding or cutting, much more flame energy is needed than cooking in the kitchen. So we have to add extra oxygen in this process, and that is why this process is known as oxyacetylene or oxy-LPG gas welding. The equipment needed for these purposes are a welding torch, injector or low pressure welding torch, positive or equal pressure welding torch. This is more commonly used in welding torch being used. Welding torch tip, these are also called nozzles. These nozzles are made of copper and its alloys. The sizes are governed by the diameter of the opening. The diameter of the tip opening for welding depends upon the type of metal and its thickness to be welded. This is the picture of a typical gas welding torch. You can see that there are two connections here. There are two connections here. One is colored blue and another is colored red. These are two flow control valves, and they are used to control the flow of the oxygen gas or the acetylene gas. This is the handle where the welder is holding the torch, and this is the mixing chamber where this oxygen and acetylene or the fuel gas, it can be LPG also, they are mixed here, and at the tip the flame is generated. So while doing this process, what we do is like a burner in a kitchen. We first open the acetylene line or LPG line, and with the help of a matchstick we generate the flame here, which will be a small flame with much less energy. Now what we do is we slowly open the oxygen valve and start supplying oxygen there. Now we all know that oxygen is essential for combustion. So when oxygen is more, the flame temperature will increase. In other words, the flame energy will increase so that it will generate enough heat for welding or gas cutting. This is the shape of the gas cutting torch, which we will come later on. Now, in the cylinder, there are pressure regulators fitted on the oxygen cylinder or the acetylene or LPG cylinder. Now, we will go to a gas welding setup here first. This is actually a typical gas welding setup, where you can see that there is the oxygen cylinder, which is smaller in diameter and larger in height, and the acetylene or LPG cylinder. LPG cylinder you have all seen these days. These two cylinders are placed side by side, and on the top of the regulators of cylinders, there are the pressure regulators are there. The pressure regulators are there. Now these pressure regulators, they actually regulate the pressure, because the pressure inside the cylinder is very high and it is not workable. So through these regulators, we reduce the pressure to the output point. Now you can see that on top of these valves, there are two pressure gauges fitted. This is one pressure gauge and this is another pressure gauge. The first one, it reads the pressure inside the cylinder, and the second one, it reads the pressure which is gas is released at that particular pressure. Now the same torch is shown here, held in the hand, and the rubber hoses are connected to this torch so that oxygen acetylene comes to this point. We burn it, and sometimes we may need a filler rod, and the heat is generated in the flame and the welding is done. Now, these are the types of flames that we get in a gas welding system. First is a carburizing flame. When acetylene is higher and oxygen is lower, we get a carburizing flame, or sometimes it is called a reducing flame. You can see the inner cone is there, and there is the acetylene feather because of the excess acetylene, and the flame color is white with the border is light orange. So that is a carburizing flame. This is used mainly for alloy steels, which absorbs oxygen which has got a very high absorbing power of oxygen, and that is why carburizing flame is used. Second is neutral flame. Neutral flame, oxygen and acetylene both are in equal amount. That means 50% oxygen and 50% acetylene is mixed, and we get a colorless flame which is called a neutral flame. This is used for mostly all the general welding purpose, particularly for mild steel. This particular flame type used, that is neutral flame. Then we have oxidizing flame, which is used for mainly non-ferrous material, which are not, which doesn't have an affinity for oxygen. So we use the oxidizing flame, where oxygen is more, and the flame color is bluish to orange, and there is a acetylene feather, small acetylene feather at the root. Sorry. Small acetylene, and bluish to orange is the color. Now you see, the most important point here is that you have to judge the type of the flame by looking at these colors only, because there is no written down percentage of oxygen and acetylene, so that you can get neutral flame or carburizing flame. So that is why I am explaining the color schemes very carefully, that the welders, they identify the type of flame that is to be used by the color of the flame only. Okay, so we will go to types of flames we have already seen. Now this is the equation that goes on in the flame. Say if it is acetylene gas, you know the formula is C2H2, it combines with oxygen and it generates carbon monoxide is generated along with hydrogen. Okay. Now, carbon monoxide is a very, very unstable gas. So, in the second stage, it gets combined with oxygen and that hydrogen also combines and it forms carbon dioxide and H2O. This particular equation, this C2H2 plus O2, it takes place at the, at the core of the flame, where the temperature is to the tune of 3000 degrees centigrade, and then gradually the temperature reduces and the second stage comes up with this particular expression. Now that means, you see, when we have a flame, the tip of the flame is cooler than the core of the flame, and we take the flame nearer to the object first and nearer, and first it becomes red hot, and then in the hottest zone it punctures and it cuts or it does the welding. This reaction takes place in the larger blue flame which surrounds the whitish cone flame. This larger blue flame contributes only a preheating effect. That's what I said, that the tip of the flame is used for preheating only, and then the core section comes which produces either the cutting action or the welding action. Okay. Types of flames we have already discussed, and these are some of the applications. Cast steel, we use neutral flame, no flux is needed. Filler ware, if you need, is a steel filler ware. Now for lower thickness, you may not need any filler ware, directly it can be fused together. Say thickness means less than 3 millimeter, but if the thickness is more than 3 millimeter, then you will need a filler ware for a proper welding to take place. In steel plate we use neutral flame. In high carbon steel, as I said, that high carbon steel and alloy steel, they have got an affinity for oxygen, so there we use reducing flame, where acetylene is more and oxygen is less. And wrought iron is oxidizing, grey iron is oxidizing, cast iron pipe neutral, and chromium steel is neutral flame, and mild steel is always neutral flame. So these are the use of the different flames, and I do not want to go into the technique now. Now we will just briefly go into the gas cutting process, because actually in industry gas welding use is much less now. Most of the welding is done by electric arc welding. Gas welding is used for gas cutting extensively, where the only difference is that in welding the amount of oxygen we use is much less than we require in gas cutting. That is why in gas cutting torch, I will go back to gas cutting torch now. This is the gas cutting torch. You see, the same thing is there. The nozzle tip is a little smaller, and there is an extra pipe for the high pressure oxygen gas to be injected separately for gas cutting. There are two inlets again, but the gas comes here, and the high pressure gas, it actually comes out when this particular lever is pressed. So normal blue and red lever, they will supply normal oxygen and normal acetylene to form the flame, but when you press this particular lever, then extra oxygen supply will be there and cutting action will take place. Because please remember that gas cutting is cutting by oxidation. It is cutting by oxidation and by no other process, not by heating only. So you require, for the oxidation, you require extra oxygen. In welding we try to avoid oxygen, and in cutting we use more oxygen for cutting. Okay. So there is this is the gas cutting setup. Now here you can see the multiple gas cutting nozzles that are used in a profile gas cutter. See, this is very widely used in industry, and any industry will see this. See, there are 4 torches mounted on the machine which can move both in the x-axis and y-axis automatically. And if you see for a particular profile, if that profile is programmed into the computer, this is a CNC controlled gas cutter, then you know that particular profile will be automatically cut at 4 places. So at 4 places. So you can imagine the productivity in one stroke, 4 number of components will be cut in different profile. The profile that you feed into the program, that particular profile will be generated, and large number of profile cut components can be taken out. I think we finish our lecture today at this stage, because we have finished gas cutting, gas welding, and then in the next lecture we will cover the electric arc welding process. Thank you.